everyone. Today, we're diving into something pretty wild, using AI to, automatically translate old C code into Rust.
Oh, yeah, I've seen some stuff about that.
You know, memory safety is a huge deal in cybersecurity, right?
For sure.
And C has kind of a bit of a reputation.
Yeah, for being a little vulnerable,
Yeah, exactly.
to put it lightly.
So we're going to be looking at an article from Slashdot about this DARPA project.
DARPA always doing the crazy stuff.
I know, right? It's called Tractor, which stands for Translating All C to Rust.
Wow, they really...
It's ambitious.
Yeah, shoot for the stars.
And even they admit some code like the Linux kernel might be too complex.
Yeah, that doesn't surprise me.
But first, can you just give us the quick explanation of why memory safety is such a big deal?
Okay, so imagine building a house, right?
Mhm.
C is give you all the tools, the wood, the nails, everything, but no building codes.
Oh.
So you can build a masterpiece.
Yeah.
Or it can fall apart.
Okay, so that's a good analogy.
Yeah, so Rust is like having those codes built in. It's way harder to mess up.
So that's why everyone's so excited about this DARPA project.
Yeah, they want to eliminate memory safety vulnerabilities once and for all.
That's from the article.
Yeah, it's very DARPA,
No, right.
aiming high. But it's a DARPA hard problem for sure.
So they're turning to AI for help.
Well, someone's got to do it right.
Right. And the article mentions that some AI chatbots can already do a decent job with this C to Rust translation.
Yeah, I've played around with some of those.
But it's not perfect, obviously.
Not even close.
So what makes this translation so tricky?
Well, first off, C and Rust just handle memory totally differently.
Right. You were talking about that earlier.
Yeah, like with the house analogy.
Right.
And then there's pointer arithmetic in
Mhm.
C. That's a real headache.
I can imagine.
It's like a whole other language almost.
And the AI has to understand the intent of the code, not just blindly translate.
Exactly.
Yeah.
It needs to know what the programmer was trying to do.
Which is probably why they're running into issues.
Yeah, it's not just about syntax. It's understanding the nuances.
Speaking of nuances, the Slashdot comments are a goldmine.
Oh, yeah. People have some strong opinions.
There's so much debate whether this is even a good use of taxpayer money.
That's always a hot topic with DARPA.
For sure. One commenter suggested just using AI to find and fix the bugs in C directly.
Makes sense on the surface, right?
Yeah, why bother translating if you can just patch up the old code?
But then you're just playing whack-a-mole.
Right. Constantly fixing bugs instead of preventing them.
Which is the whole point of Rust. It's designed to prevent those bugs in the first place.
Another commenter compared AI bug checking to syntax checkers and IDEs.
Yeah, it's similar. But an AI bug checker would ideally be way smarter.
It's it could understand the logic of the code.
Yeah, and spot potential issues, even if they haven't been specifically defined as bugs.
But some people are worried that this AI bug fixing could actually introduce new W flaws.
It's possible, I guess.
Yeah, if the AI misunderstands something or makes a bad decision.
And it can be tough to even detect those new bugs.
Right, because they're not the known vulnerabilities that we're used to looking for.
Yeah, it's a whole new level of complexity.
Okay, so we've got the potential benefits, the challenges, the risks, but let's talk about this philosophical divide between C and Rust.
Oh boy, here we go.
Because it's not just about technical features, right? It's people have these strong feelings about their preferred language.
It's almost like a religion for some people.
I know, right? C is all about performance and control.
Right, very hands-on.
And Rust is about safety and reliability.
So it attracts different types of programmers.
Like choosing between a sports car and a minivan.
Exactly. Both can get you there, but the experience is completely different.
And sometimes those preferences clash.
Especially when you've got people who are really invested in a particular way of doing things.
So how do we bridge this divide? Can we find some common ground between these two worlds?
That's a great question, and one we'll explore further in our next segment.
Stay tuned, folks.
Welcome back to our deep dive.
So we've talked about the reasons behind this whole C to Rust thing, the security risks, the benefits of Rust. But how would an AI actually do it? How do you teach a machine to translate code?
It's like teaching someone a new language, right?
Right.
You wouldn't just give him a dictionary and say, go read Shakespeare.
Yeah, that's true.
You got to start with the basics. The AI first, it breaks down the C code into its parts, variables, functions, pointers, all that.
So it's kind of like dissecting the language.
Yeah, like a code linguist.
Yeah.
Figuring out the structure.
Okay, that makes sense.
But it needs to understand both C and Rust to know how to map the ideas from one to the other.
Right, like a bilingual dictionary.
Yeah. Simple stuff might translate directly.
Yeah.
But memory management,
Oh, boy.
that's where things get
The
messy,
C is like, here's the memory. Do what you want.
which is how you get those nasty bugs.
Exactly. But Rust is strict. It's got all these rules about who owns what data.
So the AI can't just do a word-for-word translation?
Nope. It has to figure out how to make the C code work with Rust's memory rules. That sounds super complicated.
It is. It's like translating a legal document from one country to another.
Oh, I see. You can't just change the words. You have to understand the whole legal system.
Exactly. The AI has to figure out how to implement those memory concepts in Rust.
Like rewriting whole sections of code, probably?
Sometimes, yeah. And this is where things get tricky even for AI.
How so?
Well, it's not enough to just translate the code. It needs to be good Rust code, like something a human would write.
Oh, right. It can't just be a jumbled mess.
Exactly. It needs to be what they call idiomatic, meaning it follows the style and best practices of Rust.
So it's not just about being correct. It's about being elegant, too.
Exactly. And that comes down to how the AI is trained.
Like if you feed it bad code, it'll learn bad habits.
Yep. But if you train it on really good code, it'll pick up those subtle nuances.
Okay, so let's say we have this amazing AI that can translate C to Rust flawlessly. What changes could this bring?
Well, first off, cybersecurity would get a huge e-boost. Imagine all that old C code in critical systems being made safer.
It'd be like a security upgrade for everything.
Yeah, without having to start from scratch.
Ah,
And it could change how new software is written.
how so?
Well, developers can maybe focus more on the features and performance early on.
And then let the AI handle the security stuff later.
Yeah? It's like having an AI bodyguard for your code.
But there are downsides, right?
Of course.
Hmm.
No technology is perfect. One worry is that developers might get lazy.
Like they'll just rely on the AI to fix everything.
Exactly. And that could lead to sloppier code overall. And then there's the trust issue.
Can we really be sure that the AI translated code is truly safe?
It's a valid concern.
Hmm.
We're talking about critical systems here.
Mm-hmm.
You know, power grids, financial systems.
Stuff that can't afford to go wrong.
Right. So we need ways to test and verify that this AI-generated code is actually secure.
It feels like we're entering this whole new era of programming.
We are. The line between human and machine is getting blurrier.
And we have to figure out how to navigate that.
Exactly. How does this change the role of programmers? What new skills will they need?
That's a perfect segue to our next segment where we'll explore those very questions. So we've talked about the tech, the security, even the philosophy behind this whole C to Rust thing. But what about the people? You know, the actual programmers.
Right. It's easy to get caught up in the technical details, but we can't forget about the human side of this.
Exactly. Like if AI can do all the coding, does that mean programmers are out of a job?
Well, I don't think it's that simple. AI will definitely automate some tasks, but it's not going to replace human programmers completely.
So it's more like a tool then.
Exactly. Like
Yeah.
a really powerful tool that can help programmers do their jobs better.
Okay, so instead of being afraid of AI programmers, should be learning how to use it.
Right. Think of it like a pilot and autopilot. The autopilot can handle the routine stuff.
Yeah.
But the pilot is still in control.
Oh, I like that analogy. So in this new world of AI coding, what skills are going to be most important for programmers?
Well, first off, you still need a rock-solid understanding of programming fundamentals.
So those core skills are still going to be in demand.
More than ever, actually. Because AI can handle the grunt work, programmers can focus on the bigger picture. You know, the design, the problem solving.
So it's like the difference between a bricklayer and an architect.
Exactly. The bricklayer lays the bricks, but the architect designs the building. And as AI gets smarter, programmers need to be able to think like architects.
So it's not just about writing code anymore. It's about understanding the whole system.
Right. And being able to guide the AI in the right direction, which means good communication skills are going to be super important too.
Because you have to be able to explain things to the AI and to other humans.
Yeah, it's all about collaboration, working together to create something awesome.
It sounds like programming is becoming less about solo coding and more about teamwork.
Definitely. And that's something for all our listeners to think about. Are you ready for this new world of AI-powered coding?
It's definitely coming, whether we're ready or not. And like you said, it's not just about the tech, it's about us. How do we adapt? How do we make sure this technology benefits everyone?
Those are the questions we need to be asking. And that's what this deep dive has been all about, exploring the possibilities, the challenges, and the potential impact of this incredible technology.
We've covered a lot of ground today, from the nuts and bolts of memory management to the philosophical implications of AI. It's a complex topic, but hopefully we've given you some things to ponder.
And we encourage you to keep exploring, keep learning, and keep those conversations going.
That's what it's all about. Thanks for joining us on this deep dive. Until next time, keep those critical thinking caps on.